The goal of today's lesson is to be able to classify triangles either by angles or sides, and then eventually by both. So let's start with angles. The way we classify triangles by angles is we decide what types of angles are inside those triangles. So if a triangle has 3 acute angles, which means that they are less than 90 degrees, we call that an acute triangle. If a triangle has 1 obtuse angle, just one right here, we call that an obtuse triangle. The way we notice that something is a right triangle is if it has 1 right angle. Notice it has the box in the corner, so we call that a right triangle. And the fourth type, which we don't usually do very often, if it has 3 congruent angles, it is called an equiangular triangle. Okay, so you look at the types of angles inside the triangles, and it'll tell you which type of triangle it is. So let's try some. So if we're looking at the diagram over here to the right, and I'm trying to classify CDE based on what type of triangle it is, so I'll look at CDE here. CDE is right here. Now notice I have the box in the corner right here. That tells me automatically that it's a right triangle. Now if I look at triangle BCE, grab a different color pencil here. So we'll say BCE. BCE. Now I notice that angle C right here is an obtuse angle, which makes this an obtuse triangle. Alright, let's look at triangle ABE. ABE. ABE is from A to B to E. Now what I notice is that I have markings in all 3 corners. I have a marking here, a marking here, and a marking here. Since those have the same 3 markings, that means these angles are congruent, which means I have all 3 congruent angles, and that is going to be an equiangular triangle. Now if you also said acute triangle, you'd also be correct. Let's look at triangle BDE. So BDE, if I trace from B to D to E, that's right here. Now what I notice is that B is acute, D is acute, but E is obtuse. So since I have 1 obtuse angle greater than 90, I'm going to call that an obtuse triangle. And finally, triangle CFE, I'll trace from C to F to E. So I trace from C to F to E, this triangle in here. I notice that C is an acute triangle, F is an acute triangle, and E is an acute triangle. If I have 3 acute angles, that would be an acute triangle. Now notice it's not an equiangular triangle because we don't have 3 markings in all 3 angles here. Alright, moving on to classifying by sides. If we have 3 congruent sides, that is called an equilateral triangle. Now notice what it has on all 3 sides here to show that they're congruent is these little markings right here. These markings show that these 3 sides are the same. They're congruent. In the next diagram, I have 2 congruent sides. Notice only 2 of them have marks on them. So when I have 2 congruent sides, that's called an isosceles triangle. Notice there's only markings on 2. The third side is different. And notice on the third one I have no congruent sides. There's no markings. All 3 sides are different. We call that a scalene triangle. Again, all 3 congruent sides with 3 markings will be an equilateral. 2 congruent sides with 2 markings will be an isosceles. And if I have no congruent sides, I can't assume any of them are equal. I call it a scalene. Alright, let's look at triangle JKM and just classify it by angles. So, or by sides, sorry. JKM. 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 Now let's see, I have a marking on JK, but no marking on KM, and no marking on JN, or JM, sorry. So I have nothing to tell me that any of those sides are the same. Scaling. Now let's look at triangle KLN. So if I take a different color and trace from K to L to N, I have this one right here, K to L to N, and back to K. Notice right here I have, on KL I have 2 markings. From L to N I have 2 markings. And from K to N I have 1 marking. Well, it looks like these two are the same, but this one is different. Head back up here. When I have 2 sides the same, that's called isosceles. Lastly, triangle JKN. So if I trace from J to K to N and then back to J, notice on the 3 sides I have marking here, single marking here, single marking here. All 3 markings are the same, which tells me all 3 sides are congruent, which tells me that I have an equilateral triangle. Now you may want to pause the video and try the next 6 items, classifying them by angles and sides, and then unpause when you've attempted them to see if they're correct. I'm going to classify each triangle by angle first and then by sides. So again, my choices for angles are acute, obtuse, right, or equiangular. And secondly, my choices for sides are equilateral, isosceles, or scaling. So going by angles, I notice right here I have a box in the corner that automatically tells me I have a right triangle. Now looking at the sides, I notice that there are 2 markings here, each single lines, which tells me that those are congruent. I have 2 congruent sides, isosceles. Number 10, I don't have any markings on the side, but I don't have any angle measures other than the fact that I have a 114 degrees right here. 114 degrees is greater than 90, which tells me it's an obtuse angle. When I have one obtuse angle, it's an obtuse triangle. And judging by sides, I don't have any markings on any side, so regardless of whether it looks like 2 sides are the same or not, you can't tell because there's no markings to say they're congruent. That means it's a scalene. Number 11, they're giving you angle measures in all 3 angles, along with measures for all 3 sides. So let's go angles first. I see an angle measure of 60, 60, and 60. All 3 angles are the same. You have a choice of 2 vocabulary words, either equiangular or acute, and either would be correct. But the more accurate one would be equiangular triangle. Now if I'm looking at sides, classifying by sides, I have a 7 centimeter side, a 7 centimeter side, and a 7 centimeter side. If I know all 3 sides are congruent, regardless if it has the markings or not, it has the measures in numbers, all 3 numbers are the same, we're going to say equilateral. And by the way, whenever we have an equiangular triangle, it is also going to be equilateral. They go together. Alright, looking at number 12. Now I don't have any angle measures in here. However, I'm going to look if there's any right angles. I don't see a marking for a box. Then I'm going to look for an obtuse angle, because if I have an obtuse angle, that means it's an obtuse triangle. I don't see any obtuse angles. We have an acute angle, an acute angle, acute angle. That makes an acute triangle. Now, if I'm judging by sides, I have a side length of 15 inches, 18 inches, and 20 inches. That means no sides are congruent, which makes it a scalene triangle. Number 13, if I go by angles alone, I'm looking for acute, obtuse, or right. I notice right here, right away, I have a box in the corner. That means I have a right triangle. That's a dead giveaway. Now, with no markings telling me whether any of these sides are the same, I can't assume any of them are the same. So I'm going to say they're all different and call it a scalene. Number 14. Again, I'm looking for angles first. I only have one angle measure of 97 degrees. 97 is bigger than a right angle, which makes it an obtuse angle, and all I need is one obtuse angle to make it an obtuse triangle. Now going by sides, I have a side of 5 feet, 5 feet, and we don't know. However, if it gives us two congruent sides, they don't need to put the markings, they tell us the numbers. What we do know is that if two are the same, we call it isosceles.